Hi class, this is Mrs. Lyons. This is just a quick video to kind of summarize all of our different mole conversions. We've converted between atoms and moles, we've converted between moles and grams. Now we want to kind of put that all together. We know that when we're converting between atoms to moles, we use Avogadro's number, 6.02 times 10 to the 23rd. And when we're converting between moles and grams, we use the molar mass on the periodic table. Okay, so depending on what we're doing, our conversion factors would be one of these three. A mole is equal to 6.02 times 10 to the 23rd atoms. A mole is equal to 6.02 times 10 to the 23rd molecules, so those two are basically the same thing. And then 1 mole is equal to the molar mass in grams from the periodic table. So we're going to use one of these three conversion factors to do any mole conversions. Because we can now say, we said 1 mole is equal to Avogadro's number, and 1 mole is equal to the mass in grams. So what that tells us is that we can say 6.02 times 10 to the 23rd atoms is equal to the mass in grams by combining those two equations. So let's look at an example. So this is how many atoms in 3.4 grams of carbon. So in the problem, our given is 3.4 grams of carbon. We're looking for the number of carbon atoms. So we're going to use our conversion factor is going to be 6.02 times 10 to the 23rd atoms is equal to 12.01 grams of carbon. So let's set this up. So always given goes here. So 3.4 grams. All right. So in this case, we want grams on the bottom. So 12.01. I got that from looking at the periodic table for carbon. And then on the top is going to go 6.02 times 10 to the 23rd atoms. Let me plug this into my calculator real quick. I'm going to plug in 3.4 times 6.02. Don't forget to use your exponent button. Times 10 to the 23rd divided by 12.01. So what my calculator tells me is 1.70424 times 10 to the 23rd. Let's see, I can only have 2 sig figs. So my final answer is going to be 1.7 times 10 to the 23rd carbon atoms. All right, let's do one more. This one says, how many grams is 4.96 times 10 to the 24th H2O molecules? Okay, so we know that we have 4.96 times 10 to the 24th molecules. We're looking for grams of water. So our conversion factor is going to be Avogadro's number, 6.02 times 10 to the 23rd, is equal to 18.02 grams of water. That's the molar mass. So if we look at the periodic table, hydrogen has a molar mass of 1.01. We have 2 hydrogens. Oxygen has a molar mass of 16.00. We have 1 of those. If we put that together, we get 18.02 grams per 1 mole of water. So we're going to plug this in to our equation. So I had 4.96 times 10 to the 24th water molecules. All right, and I'm going to set up my conversion factor, my truth table. Now I want molecules to go down here, so I know the number that goes with molecules is always going to be Avogadro's number. So I have 6.02 times 10 to the 23rd molecules is equal to that molar mass that we calculated, 18.02 grams. So now, again, I'm going to plug this into my calculator. I've got 4.96 times 10 to the 24th times 18.02 divided by 6.02 times 10 to the 23rd. If I do this math, my calculator says 148.4704. And that would be, if we cancel out our molecules, that would be grams I can only use 3 sig figs though, so I'm going to round this to 148 grams of water. All right, so very quick video on how we go about converting from either atoms or molecules to grams, or the other way from grams to atoms and molecules. If you have questions, be sure to come in on a blended day, or make an appointment to check in with me if you're in a traditional class. That's all for now. See you in class.